Hello, everybody. I hope you are well. Welcome to the second video on our pre-calculus course, Math LAM. Today, what we are going to cover as a topic is very much of a follow-up from the previous one. That is, we're going to be building upon the rules of exponents that we covered last time, and we're going to be adding to this the notion of FOIL, right? So you probably remember this from high school, meaning first and outside and inside and last. We're going to review this together. So how does that work, basically? What is the rule that seems to be at the heart of this chapter? Well, it's actually pretty simple. As you may remember, the FOIL rule actually goes like this. If you have A plus B that multiplies C plus D. And the best way to actually take care of an expression like this is to FOIL. So basically, first with first. So A times C, that's the F in FOIL. F for first terms. So that would be AC, like in air condition on a hot summer day. And then you're going to go A times D. So this is basically the outside terms, right? So the A and the D, what's A times D? Well, it's just AD. And then we go B times C. These are the two inside guys, right? So the I in FOIL for inside. So plus B times C. And finally, the last guy, so the last of the first bracket with the last of the second bracket. So that's B times D. All right, do we have to learn this formula by heart? Of course not. We don't, because basically all we have to do is remember on how the arrows actually go. And whenever we encounter a problem that needs to be FOILed, well, we just basically apply the rule. And that's what I want to practice with you guys today. Basically, using a lot of exponents that we covered last video so that we actually reinforce the notions we learned. A special case of the FOIL that we are going to encounter today. Special case. There's actually two of them. So number one, here's A plus B squared. Aha. A plus B squared we're going to encounter in this course a lot. Pourquoi? Because we're going to encounter this a lot in Calculus 1. Everything we're doing in this course actually relates to Calculus 1. I mean, everything. So how would you do this? Well, you simply have to remember that the square to the bracket means, just like it does for numbers, times itself. So A plus B squared is just A plus B times A plus B. And then what do I do with this? I FOIL. So that is A times A, which of course is A squared, right? A to the 1 plus 1. And this is A times B, which is AB. And then this is B times A, which is BA. And then this is B times B, which is B à la 2. So that can be simplified. Yes, of course. Yes, it can. Yes, it can. So A squared plus AB. Now, BA, what's BA? Well, it's going to be the same thing as AB. Why? Because 2 times 7 gives you the same thing as 7 times 2. We say that multiplication is commutative, right? So B times A is the same thing as A times B. So basically, what we're saying here is that in the very end, we get A squared plus, here's a notion. AB plus AB. X plus X, 2X. AB plus AB, 2AB. 2AB plus B squared. Good. Well, that would be special case number one. You can probably guess the next case, which will be similar, but perhaps a little more involved. It'll be A plus B to the power of 3. What's A plus B to the power of 3? Well, it's a plus b to the power of 2 times a plus b to the power of 1. Right? Because when I multiply two things with the same base, what do I do with the powers? I add them. 2 plus 1 is 3. But look, we already know what a plus b squared is. We already worked it out over here. So straight up, I can say that this is a squared plus 2ab plus b squared. And that's going to be multiplied by a plus b. Now we get a special case of FOIL. Instead of having two terms multiplying two terms, now I have 1, 2, 3. 3 terms multiplying 2 terms, right? In the language of mathematics, this is called a trinomial. And this is called a, what is it called? Binomial, that's right. Trinomial times binomial. What does that actually change for me? Absolutely nothing. Why? Because it's the same FOIL, but applied this time to this guy times this, and then the a squared times b. So the first with the other two. Then I'm going to do the middle one times the other guys. And then finally I'll do the last with the b. So what will I get? Well, I'll get something like what? What will I get? A squared times a. So first times first. What's a squared times a? A3. A squared times b. Not much I can do about this. A squared b. Now, middle term. 2ab times the first, a. What's 2ab times a? What's 2ab times a? The a times a will become? A times a will become a squared. So 2a squared b. And then I got 2ab times b. B times b, b squared. So plus 2ab squared. Looking good. Last term, b squared times a. Well, that's the same thing as ab squared, right? Again, multiplication is commutative. I can switch them around when it's a multiplication. Et finalement, ultimamente, b3 times b1, rules of exponents, same base, you got to add the exponents. So I would get something like, oh, look at this. I got a couple of what's called like terms, les termes semblables, like terms. A squared b plus 2a squared b. That would be one of these plus two of the same. That's 3a squared b. And look at that, similar term, 2ab squared plus ab squared, 2ab squared plus ab squared. That's 2 of a kind plus 1 of the same kind. These are like terms because it's a to the 1 and b to the 2 in both cases. So that will simply give me what? 3ab squared plus b cubed. Don't learn these formula by heart. No use. Know simply how to use them, how the arrows actually distribute upon brackets, and we shall be fine. Let's practice this, shall we? Let's get rid of all that stuff. And I've prepared a few problems that will illustrate what I want to do with you guys today. Now remember that we will actually revisit this when we meet in class later on this week. So if you have any questions, you write them down. If there are some elements in the solving of the following problems that you would like to revisit, you can ask when we meet in class again later on this week. So without any further ado, I have a couple of examples for you. Here is example 1. I'm going to start labeling those, okay? Labeling those means give them some starage. Qu'est-ce que ça veut dire? What is this starage? Why do we put little stars to the problem? 1 star problem means super easy, baby stuff. 2 stars, all right, not baby, but not that hard. 3 stars, okay, now you're starting to talk. Now you're in the range of what could be on a test. 4 stars, that's pretty much as tough as it gets. There's no 5 stars, right? So 2 stars means intro problem, not that hard. Looks like this. Simplify, it's always simplify. Simplify, what do I got here? 3x squared times x squared minus 2xy plus y squared. Good. How would we do that? How would we do that? Well, this is 1, 2, 3 terms in the bracket, so a trinomial times one single term. We don't care. It's still the same thing. It's still the FOIL method, and we just have to multiply the 3x squared with all three guys. So this is 3x squared times x squared minus 3x squared times 2xy plus 3x squared times y squared. That's a times, that's a times, and that's a times. If you want, you can put brackets here. No hurt. No, nothing bad done if we do that. It's not super necessary, but if it helps you see what's going on, do it. Rules of exponent. x2 times x2. That's x to the 2 plus 2. x4. Minus. All right, I got constants. 3 times 2, well, if I'm not mistaken. Where's my calculator? Where's my calculator? 3 times 2. 6. X squared times x to the 1. Rules of exponent. x2 times x1. x3. And there's a lone y here, so y to the 1. Plus, not much I can do about this last guy, yes, 3x squared y squared, so 3x squared y squared, c'est tout. That is as simplified as this will get. You can box this as your final answer, and now you understand why this is a 2-star problem. It's pretty easy, it's pretty straightforward. Yes? Moving on to exemple 2. All right. Exemple 2, let's hike it up to, I can't give this 3 stars, I can't give this 2 stars, so I am going to give it 2.5 stars. Always compromise, man, you got to compromise. Between 2 and 3, there's a half. So simplify 3x moins 1, multiplying 4x squared, minus 8x plus 3. All right. Ooh, what do we got here? Yes, this is called a binomial, which actually multiplies a trinomial. Who cares what they're called? We do first times each of the guys. And then when we are done, we're going to do last times each of the guys. Yeah! Comes up. So the first with each of these, so I will have what? 3x times 4x squared. I'm really taking my time by writing this down. If you want to go directly to 12x3 when you work out your own problems, go ahead, no problem. I'm just going to take my time here. So 3x times the middle guy, 8x, plus the last of the 3x multiplication, so the last guy, times 3. And now I'm done distributing the 3x upon all 3 terms of the trinomial. Minus 1, so minus 1 times 4x squared, minus 1 times minus ax, and minus 1 times 3. Well, that's what you get upon distributing all these terms in the proper order. So we're going to take care of each bracket. So like we said, this is 12x to the 3 because 3 times 4 is 12, and x to the 1 times x to the 2. Bang! It's x to the 3. What is this guy? 3 times 8 is 24, 24, 24, and x times x is x squared. Still with me? Yeah? 3x times 3. Well, that's 3 times 3 and only 1x. And these are easy because it's just really a minus in front of each bracket. So minus 4x squared plus, minus minus, huh? Minus minus, always a plus, minus 3. Very good. Very good, very good, very good, very good, very good, very good, very good. Now what? Are there any like terms in here that I can actually bring together? Like terms mean that they really have to be exactly the same in terms of x's. Well, this is an x squared, and well, this is an x squared. So these two terms, this guy and this guy, they are called like terms because they are both x squared. And if we want to talk again the language of like terms, this is an x and this is an x. So this guy and that guy are also like terms. So collecting these together, I do believe we are about to spit out our final answer. Starting with this guy, 12x3. Now what do we say like terms? Minus 24x3 minus 4. Minus 24 minus 4, that would be minus 28x2. In green, 9x plus 8x, that would be 17x. And the lone constant, minus 3. And that's how this simplifies. So far so good. Let's hike it up a little bit. Again, if you have some questions when you see this video, jot it down, and when we meet in class later on this week, you can ask me. Ok, alors exemple 3. Example 3, example 3, it is still a 2.5 star. So example 3, it is still 2.5 stars, not going to change that. Simplify this time. All right, let's bring about some of these fractional exponents that we hate, but it's not because we hate them that we have to be oblivious to them. We need to be able to manipulate this in Cal 1. Everything we do in this course is related to Calculus 1. Entonces, a binomial and a binomial. It's the FOIL again. It's the FOIL always. So x to the 1/2 times x to the 1/2, x to the 1/2 times y to the 1/2 avec un moins. And then I'll do this times this, and then I'll do times this over there. All right, so here we go. X to the 1/2 times x to the 1/2. That's what it is. Plus x to the 1/2 times, I better put a bracket there because I got a minus. Looks better this way than without. Plus, I am now down to distributing the last term of the first bracket, y to the 1/2, times the first of the second bracket, x to the 1/2. This is a times. Plus y to the 1/2. Yeah, this guy. Yeah, this guy. Times the last guy of the second bracket. Times, I'm going to put a bracket there, minus y to the 1/2. Why? Because it looks better with a bracket. Okay. X to the 1/2 times x to the 1/2. Same base. Add then these exponents. That's 1/2 plus 1/2. Yo, that's 1. Absolutely. A plus times a minus. That will be a minus. So x to the 1/2 times y to the 1/2. Not much more that I can do with this because they are not the same base. One is an x, one is a y. So I can't really merge them together. Plus, remember, 2 times 7 is equal to 7 times 2. I'm going to switch these around. That's x to the 1/2 times y to the 1/2. And here's again a plus times a minus. And here's a y to the 1/2 times y to the 1/2. That's y to the 1/2 plus 1/2. And what's 1/2 plus 1/2? You got it. It's y to the 1. So, I believe that we are ready for the final answer already. What is the final answer? Well, take a close look at this guy. What is x to the 1/2 y to the 1/2 with a minus added to x to the 1/2 y to the 1/2 with a plus? They will absolutely cancel each other. And what we got here, ladies and gentlemen, you did not expect that, huh? Very simple answer. X minus y. Yes, sir. Yes, ma'am. All right, cool. Let's hike it up to 3 stars, shall we? Let's hike this up to 3 stars. So, example 4. Let's hike this up to 1, 2, and 3 stars. All right, I'll pick you up later. So this is gone. let's see what we got there. So it's got to be a little more complicated than the one before. How could it be more complicated than the one before? Well, we are going to put a little square to the bracket. A to the 1/2 plus b to the 1/2, and we're going to put a square. I'm going to put 3 stars to this, although you might disagree. You might think that this is really not complicated, and you know what? You might be right. But let me share with you a little nugget of the things that I see when I grade quizzes, assignments, tests, and exams. Here's what I see. I see a to the 1/2 times 2 plus b to the 1/2 times 2. Some people have done this in the past. They distributed the 2 onto each of these guys. Is that something that can be done? Is that kosher? Is that algebraically correct? The answer is no, I cannot do that. There is no algebraic rule that allows me to take this exponent and give it to both of these terms when they are separated by a plus or a minus. Okay? So remember, so before we work this problem out together, if you have a plus b to the 2, don't write this as a squared plus b squared. Don't give the 2 to both the a and the b. And what I just said holds true as well if there is a minus between those guys. This is never a squared minus b squared. Okay? Now, if there were a multiplication, well, that's the rule of exponent we saw. That's where you can actually distribute the 2 to both if it's a multiplication, or the little cousin of the multiplication is the division, and it obeys the same rule. These are kosher. These are okay. This is fine, and this is fine. This is not fine, and this is not fine. All right? So some of the do's and don'ts of the world of algebra, plus or minus, cannot give the exponent. Times and divide, yes I can, yes I should, yes I want to. Okay. Let me get rid of this, and we have a problem at hand that we need to solve. How do you suggest we solve a to the 1/2 plus b to the 1/2 to the power of 2? Well, if you're thinking about the power of 2 to actually mean power of 1 times power of 1, you are definitely along the right lines. Power of 2 means times itself. The only correct way, the only algebraically safe way to expand, that's actually what this is called, to expand this bracket squared is to multiply it by itself. And there again, we find ourselves in a FOIL situation as we're about to do this times that, this times this, and this times that. Yes? Good. So this is a to the 1/2 times a to the 1/2 plus a to the 1/2 times b to the 1/2. Then b to the 1/2 times a to the 1/2 and b to the 1/2 times b to the 1/2. That was a mouthful. So a to the 1/2 times a to the 1/2. I'm going to add my exponents. 1/2 plus 1/2. Tout le monde sait ça. Everybody knows this. It's a to the 1. This, well, I can't do much about this, can I? Because they're not the same base, so I'm going to leave them for now. A to the 1/2 comes up. 2 times 7, 7 times 2. This is a multiplication. It is commutative. I'm going to switch them terms around. Y, you're going to see y in a minute. B to the 1/2 times b to the 1/2, same base. B to the 1/2 times b to the 1/2, same base. I'm going to add them up. 1/2 plus 1/2 is 1. The reason why I switch those around, it's because now it becomes way more apparent that these are like terms, right? They're exactly identical. So one of these plus one of that gives me my respuesta final, a plus 2 of these guys, 2a to the 1/2, b to the 1/2, plus just b. That's a 1/2 here. That seems to have merged with the division bar, but it should not. Ça va? Example 4. Lovely. Lovely, lovely. Moving on, I have a couple more to cover with you and then we'll be done for the day. Exemple número 5. 5, 5, 5, 5, 5. What do I have for example 5? Oh, I think I'm going to raise this steak to 3.5 stars. This is starting to be serious. This is a serious problem. Serious problem, simplify. A to the 2/3 minus b to the 2/3. Oh, those fractional exponents galore. They're everywhere in Cal 1. So that's why we're paying some attention to them in pre-cal. Multiplied by a to the 4/3 plus a to the 2/3 b to the 2/3 plus b to the 4/3. So we've done a binomial times a trinomial times a trinomial. So we know how. It's just going to be a little more complicated because of all these fractional exponents. Well, more complicated, not that much, right? We're going to do first with first and first with second and first with last. And then when we are done with this, we're going to do the same with this term. Comes up. All right, so without any further ado, what is it that we get? A to the 2/3, we said times the first one here, times a to the 4/3, plus a to the 2/3 times the middle term, which is a to the 2/3, b to the 2/3, plus a to the 1/3 times the last guy, which is, whoops, sorry, my bad, a to the 1/3 times b to the 4/3. That's not 1/3, sorry, again I made a mistake, that's not 1/3, it is of course still 2/3, this guy here, a to the 2/3, multiplied by this guy last, b to the 4/3. Good, now we go last term, minus b to the 2/3 times a to the 4/3 minus b to the 2/3 multiplied by a to the 2/3, b to the 2/3, et finalement minus b to the 2/3 times b to the 4/3. This is where we are going to be practicing our rules of exponents. Same base, add the exponents. That's a to the 2/3 plus 4/3. That would be 6/3, yes? 6/3, C2. Plus a to the 2/3 times a to the 2/3, that's a to the 4/3 times b to the 2/3. Plus this here stays what it was, a to the 2/3, b to the 4/3. Are these two like terms? Are they like terms? Will I be able to add them together? Nah. They have both the a and the b, but look at the power. The a has 4/3, the a has 2/3. They're not like terms, I can't add them. Minus, let me put the a in front of the b. Why? Because 7 times 2 is equal to 2 times 7. So a to the 4/3, b to the 2/3. Minus, oh, look at this, I got some like terms. B to the 2/3 times b to the 2/3. That would be b to the 2/3 plus 2/3 is 4/3. So again, the a comes first, alphabetical order, b to the 4/3. Et finalement, b to the 2/3 times b to the 4/3, I add my exponents, that's b to the 6/3, that's b to the 2. Entonces, are there any like terms I can join together? Look, a to the 4/3, b to the 2/3, a to the 4/3, b to the 2/3. One is a plus, one is a minus. Ciao, ciao, bambino. Gone, cancel, right? One's a plus, one's a minus, and they're exactly similar. Same story for a to the 2/3, b to the 4/3, and a minus a to the 2/3, b to the 4/3. Ciao, ciao, bambina. They're all gone. And look at that pretty, so very pretty answer. This is a squared minus b squared. And in our next video and the subsequent ones, we are going to learn that this is actually refactorable. We haven't talked about factor quite yet. We'll talk about that in our next video. but that probably rings a bell if you have algebra more or less fresh in your memory. You probably know what this is, but we're not going to get into that right now. It's not my purpose today. Good. One last example 6. Simplify the following. Example 6. What do we got? I'm going to keep this also as 3.5 stars because it's a cubic. So x to the 1/3 minus y to the 1/3. I want to bring this to the power of not 2, but 3. What does that mean, power of 3? X to the 1/3 minus y to the 1/3 to the power of 3. That means x to the 1/3 minus y to the 1/3 times itself, right? It's got to be multiplied by itself 3 times because that is exactly what the power of 3 stands for. Got to multiply this 3 times by itself. All right, so I'm going to start by taking care of the first 2. Let me focus my attention on these guys, which means that this will stay. This here will remain x to the 1/3 minus y to the 1/3 for now. So what I need to do here, I need your help on this. Let's go quickly over this because it's the many binomials we've done. X to the 1/3 times x to the 1/3. What is that? Same base, add the exponents, x to the 2/3. X to the 1/3 times y to the 1/3 with a minus. It's minus x to the 1/3, y to the 1/3. Now, y to the 1/3 times x to the 1/3. Again, minus x to the 1/3, y to the 1/3. Remember, you like to put them in alphabetical order. It's easy to spot your like terms if you do that. And minus y to the 1/3 times minus y to the 1/3. Minus minus is a plus. And y to the 1/3 times y to the 1/3, you add your exponents and you get y to the 2/3. So what you get in the end here is x to the 2/3. Again, like terms, one of them, two of them. So that's minus 2 x to the 1/3, y to the 1/3, plus y to the 2/3. And then times the remaining term of the cubic. And now I got a trinomial times a binomial. Wow, that is close to a 4-star problem with all of them fractional exponents. Okay, I'm going to go quickly over that again. X to the 1/3 times x to the 2/3 times x to the 1/3. X to the 2/3 times x to the 1/3. This is x to the 1. X to the 2/3 times y to the 1/3 avec un moins is minus x to the 2/3 y to the 1/3. Still with me? Middle term, minus 2x to the 1/3 y to the 1/3 times x to the 1/3. The x's will become x to the 2/3. So minus 2x to the 2/3 y to the 1/3. Agreed? Minus 2x to the 1/3 y to the 1/3 times minus y to the 1/3. First of all, minus minus will be a plus. And then I'll have 2x to the 1/3. And what about y to the 1/3 times y to the 1/3? That would be y to the 2/3. Okay, we're getting there. Hang on. Y to the 2/3 times x to the 1/3. They're not the same base, so I can't do much. So I'll just erase that smudge. And I'll just say plus x to the 1/3, y to the 2/3. And my very last term is y to the 2/3 times y to the 1/3. 2/3 plus 1/3 is 3/3 is 1, and a minus is minus y. All right, now let us see if we have some like terms. We have some like terms, x to the 1/3, y to the 1/3, and here x to the 1/3, y to the 1/3. So minus one of these plus 2 of that is what? Minus one of these plus 2 of that is 1 of that. Final answer, x plus x to the 1/3, y to the 2/3. And here, this is exactly the same as this, right? X to the 1/3, Is it? Oh man, it's not. It is not. What have I done? This with this? Oh, I've mismatched them completely. Okay, let me take a second look at that. I'm sorry about this. I'm going to take away that. I'm going to take away this and this and this, and I'm going to match them properly. What does it mean to match them properly? It means to be careful. X to the 2/3 and x to the 2/3. These two are the like terms, right? Because they both have the same exponents, x to the 2/3. I previously wrongly matched those two, but I was wrong because they don't have the same power. So x to the 2/3 is matched with x to the 2/3. Y to the 1/3 is matched with y to the 1/3. Hence, I get x minus one of these minus two of these should be three of those minus 3 x to the 2/3 y to the 1/3. And here we go. These two are also like terms because they are both x to the 1/3 y to the 2/3. So two of these plus one of these, that's 3 x to the 1/3 y to the 2/3. That's a y. And I got me minus y over there. And that will actually consist in my final answer. Voila. So we've been practicing even more than before. Those rules of exponents, I think by now they're sinking in. When we meet for the last video of this week, we will actually start to talk about elementary factoring, simple factoring called mise en évidence, so simple factoring of one term, and we'll be playing with some more of these fractional exponents. Yay! You take care of yourself, and I will see you in class later on this week. Ciao.